Good morning, Electrification Nation, and welcome to the Building Decarbonization Coalition Presents webinar series. Really glad you could join us. This is an exciting one. We've had over 115 people register for it, and I think it shows the excitement on this topic. My name is Panama Bartholomew. I'm the director for the Building Decarbonization Coalition. And looks like I'll mute everybody. There we go. And we have a really, I think, great session today on induction cooking. And the title of our session today is Induction Cooking Kills the Competition. Just a little bit of background on the Building Decarbonization Coalition. We're a multi-sectoral group of energy providers, manufacturers, building and design community, local governments, and non-governmental organizations all working together to collaboratively overcome barriers on the market side, as well as on the policy side. And so we work collaboratively on market transformation, consumer inspiration, public policy, and research and development. We released a roadmap in January of this year that you can see here. And in that, we called for a series of targets for the state to meet in order for us to be able to achieve decarbonization goals, including that new buildings being built should be zero emissions for residential by 2025 and commercial by 2028. And that by 2045, we should be completely eliminating greenhouse gas emissions from the built environment. We also called for a series of targets for heat pumps to move to 100% market share of sales by 2030. And below those numerical targets, we also had a series of less numerical and more driving goals that needed to be met if we were going to be able to meet our targets. And those included increasing awareness of all stakeholders involved with building decarbonization, ensuring a good value proposition for customers, ensuring a good value proposition for contractors and installers, getting the supply chain up and ready to go, and then aligning policies to meet all of our other goals. And so this webinar series is related to that first one, is increasing awareness. So we hold these webinars about every 2 weeks, where we bring in some of the top thinkers, disruptors, doers within the building decarbonization space in order to present on the most recent research, products, and other activities going on. And so we have a great one today. We have a great one today with Richard Young from Frontier Energy, who's going to be talking about induction cooking. But we have another great one coming up on September 5th, which is going to be on commercial hot water with A.O. Smith. A.O. Smith has just released a brand new small commercial hot water heating hot water system. And they're going to be presenting about that in the state of small commercial hot water technology on September 5th. So please join us for that. And anytime you'd like to join the coalition, we have a robust membership, but it will only be complete if you join. And so we welcome other folks to come in and join the coalition. It's a fantastic group. We have the best happy hours, and we collaboratively work to overcome some of the barriers holding back building decarbonization. So we're excited to have Richard Young talk about induction cooking. Induction cooking has really come to the forefront as one of the critical areas of market transformation that we need. And really it's about cultural transformation when it comes to cooking technology that we're going to need in order to be able to achieve our building decarbonization goals. And so Richard's going to be talking about what is induction cooking and then some work they've done with Sacramento Municipal Utility District on research around induction cooking and its benefits, and then some overall comments about the state of the cooking industry and where we need to go for building decarbonization of that. So we're really excited to have Richard, really excited to have all of you on board, and I'm going to hand it over to Richard. We're going to, because there's so many people that registered, if you have any questions for Richard during the presentation, please type them into the chat feature of the app. And Richard's going to stop at 3 different times in the presentation at key points, and then I'll read him the questions that you've written in, he'll answer them, then I'll start it back up again. So sorry we can't unmute everybody, there's too many folks in, so please use the chat feature. And with that, I'm going to turn it over. I'm going to stop sharing and turn it over to you to start sharing, Richard.
Great, Panama. Thank you so much. And we'll pull up my share here, get this guy going, get a presentation going. Welcome to everybody. We're going to have some fun today. And I will be moving quickly at some points, but I know that I have an educated audience here, so I can do that. And also this is recorded, so you can come back. If I say, I try to keep it lighthearted, I try to keep things pretty high level, but there will be a couple of charts because I'm an engineer and I can't help myself. So if you don't understand those, you can always email me, get back to it, or listen to the recording. But starting off, I want to thank all the sponsors of today's webinar, which includes the Building Decarbonization Coalition, the California Energy Commission, SMUD, PG&E, and of course, I work for Frontier Energy at this place called the Food Service Technology Center. Here is my smiling face. I'm the director at the Food Service Technology Center and have been here going on 31 years now, which is pretty amazing. Some of you know us from in the past when we were Fisher Nickel Inc. We're now Frontier Energy, but our name from our past work, fishnick.com, which is our website, and also just basically how everybody in the industry knows us, that still sticks. And we run this place called the Food Service Technology Center. If you ever see me out, you see my smiling face any place, feel free to walk up and ask me any question you have on commercial food service. It's my life. I love it very much. The Food Service Technology Center, just a really quick overview for those of you who may have never heard of us before, because we're kind of an interesting, a bit of a unicorn in some ways. Our core work is an appliance test lab that we created 32 years ago to study and create standard test methods for food service equipment. And in fact, we started testing induction cooking probably 25 years ago, and we're really happy that people are interested in it now. It's been a long time coming. We also do a lot of field research. Listen to Panama's next webinar on the hot water heaters. We're also hot water heater experts, and we'll be listening to that webinar as well, and maybe even tossing in some information. We get a lot of numbers from our field research. We do a lot of direct customer support as well. If there are people out there that are trying to build electric kitchens, that are working on net zero energy projects, anything where you're trying to go efficient in commercial food service, please contact us. We also do a lot of site audits and walkthroughs. And then, of course, we do a lot of workforce education and training. Hopefully, I'll be seeing some of you guys at the New Buildings Institute conference in October. I'll be doing a session there, so come up and talk to me and try to follow our research. We love doing all this stuff. It is our life. So what's on today's menu? We're going to start off with a section. We'll just talk about what is induction heating. We'll talk a little bit of what are the mechanics there. And then we're going to talk residential and why they matter to electrification and decarbonization. And then we'll spend some time on commercial food service, both the energy use and challenges in commercial food service, and why induction is a part of what we call the kitchen of the future. So let's start off with what is induction heating, and I think this is important to review and kind of get in our heads because it is something that most people have not come in contact with or physically seen or played with or used, and it's different from the way that we have normally heated food in the past. Here's a great graphic. Thank you, SMUD. I got this from Sherry Davis, who did a great poster and put this graphic together. So if we look at, and let me just pull up my little, there we go, now I can draw on the screen. If we look at the way that a traditional gas range works, I have flames down here, I have some radiant heat hitting the bottom of the pan, and then I have a lot of convective heat that's going up the sides, all of which is trying to heat the pan, and then I have a little bit of conduction here between the elements. But basically, I am generating a field of heat, and I'm putting this cooking vessel, the pot or pan, right into that field of heat. Now, what we're doing with induction is we actually have a coil, a high frequency generator underneath a ceramic plate. It's isolated. And that is creating an electromagnetic field that rises above that plate. And what the field is doing is it's interacting with the container itself, with whatever the pot or the pan is, and it is physically doing the heating in the pot or pan. Okay, now I've got a lot of red lines there. So, but what the thing that is most important to remember about this is that there is no physical heat coming off of the ceramic plate itself. I can turn on an induction cooktop all day long, have the thing on 11, and there will be no physical heat coming off of it. The interaction happens when I put this pot on top, and this electromagnetic field gets the electrons in that pot all excited, and they start running around and bumping into each other, and that pot heats up. Let's look at this. I found this very nifty GIF from the Volrath company, which does commercial induction cooktops. And so if we look on this side over here, we can see here's my induction cooktop. And you can see, this is really great because you can really see how that induction field is evenly spread across the pan, and you can see the field of highest intensity is right here at the bottom. But you can see how that's evenly spread. Now on the gas cooktop, you can see how that convective heat is coming up the side, and you can see some of the radiant that's coming off the bottom here, which is heating the pot. I love this graphic. So here's another great graphic that the Chariot Smud added to her poster, which we always love, which is once again illustrating the fact that the cooktop itself creates no heat. The heat is 100% created by the interaction of the electromagnetic field and whatever cooking container you put on top of that cooktop. We love to do a fun thing around here. We'll do demos. We'll have a pot of boiling water, and I'll take out a bill from out of my pocket. These days, it tends to be like a $20 bill. I can't carry hundreds anymore. Too many kids in college, and I'll put that. I will physically put that bill sticking out underneath the pot as it's boiling water. And people are like, oh my God, you're going to destroy your $20 bill. And then, of course, I pull it out and it's fine because there is no heat being generated by the cooking surface, by the induction surface itself. The surface will only ever get as hot as the pan. So if I am boiling water at 212 degrees, then the surface will be 212 degrees. That's different from a traditional electric resistance range top or a gas range top, which has a surface temperature that is much, much higher than whatever. So I could be boiling water on a gas range top, 212 degree water in the pan, but the burner itself may be at 300 or 400 degrees. Now, what are some of the benefits of induction? And I'm just going to list these now because we're going to come back to these when we get into the commercial section. But basically, I'm looking at fast, flexible, modular, efficient, controllable, safer, easier to clean, less heat released to the kitchen. We'll kind of touch on all these things as we go along. But I do want to point out one cool thing. This is the top of one of the induction cooktops that we tested. And you can see we have sort of different sized spots on top to put different pans and do different things. A smaller one up here for keeping things warm, this big one right here for cooking that big pot of pasta, and I'm going to talk about that big pot of pasta coming up here. Now, some considerations for induction. There are going to be a couple of considerations. It's a new technology. It has electronics in it. It has a higher initial cost than what you would pay for your standard coil electric range top, or even necessarily your just off-the-shelf gas range top. So there's a little bit of that. And because it has electronics, will it last as long as the Wedgwood that's in my 100-year-old house? God knows how old my old Wedgwood gas range is. I was telling Panama I can't seem to kill it. It's probably there. It was probably put in the 1950s. Would I be able to get 60, 70 years out of an induction cooktop? I'm going to say no because it's electronics. But would I love to have the induction cooktop? Absolutely. And then the final thing, which some of you probably know, but in order to get that interaction between the electromagnetic field and the pot actually has to be magnetic. There has to be some ferrous material in there. So you need some specific cookware. Not a problem for typical residential applications. Most of us have cookware that will actually do that. I do have a couple of ceramic things. If I put a ceramic thing on that cooktop, not going to work, okay? Or if I had something completely aluminum, not going to work. But in a residential situation, most of us have, cast iron skillet, absolutely perfect. We have some Le Creuset stuff that my wife got, beautiful cookware, absolutely will work perfectly. So I don't see that as a major hurdle to consumer adoption. What is our primary hurdle to consumer adoption? Why don't we see induction range tops everywhere? Why aren't people rushing out to buy them? It's because of this beast right here. You know, when I say, let's just get rid of this. When I talk about, okay, guys, sorry about that. There we go. When I talk about, you know, electrification, electric ranges, and I mention it to my wife, she just turns livid. She says, no way, I'll never have an electric range in my house. And why is that? That's because she is talking about this beast right here, this speed coil. We've all worked with those things. They call them speed coils. They're not speed coils, and they get, you know, bent, and the heat transfer is no good, and they're slow, and that's everybody's experience with electric range tops, and that is not the experience you get with an induction cooktop. It is completely different. Panama, let's take a second right here to stop and see if we have any questions about what I've just talked about on sort of the basics of induction cooktops.
We have two questions for you, Richard. One from Brian Ward is, any comment on the Panasonic Metal system, which works with non-ferrous metals? And then from Darren Schrum, are the metallic transfer plates that convert induction to non-ferrous pans effective?
So from Brian, my buddy Brian Ward. Yes, Brian. We have not yet tested any of the ones. So this is a great question, which is, how do we overcome that notion of having to use ferrous materials on an induction cooktop? And what's happening is the cooktop manufacturers are getting better and better at coupling the electromagnetic field with the potential magnetic or non-magnetic cookware that could be used on it. So they're finding ways to play with the frequency, and we're moving towards scenarios where you may be able to put an aluminum pan on an induction cooktop. We have not tested any of those in the lab here yet or had our hands on those technologies. And on the second question, same thing. I can't answer that yet because we have not had something in the lab, and being the nerdy engineer I am, I like to see things, get my hands on them, get some numbers before I start spreading the love on any technology. Any other questions, Panama?
Two more questions.
Okay.
Does the surface scratch easily? And is the energy consumption less or the same when nothing's on the stove, even if the stove is on?
Great questions, yes. Let me start with the second one first, because that's one we love to talk about. If I turn it on at 11 and I do not put a pan on the induction cooktop, it does not draw any energy. It may draw a tiny amount, like a little phantom amount for the power supply, or if I got a clock on the range top, something like that. But there is no energy used until I physically put a pan onto the cooktop, and the electromagnetic field starts to interact with the cookware. As far as the scratching, in commercial applications, the tops that they use, these ceramic glass tops, are extremely tough. I have not gone out to our sample induction cooktops and taken things and tried to grind the top on them to tell you just yet. Everyone that I've come in contact with has been really robust and hard to scratch. But I will, you know, once again, just qualify that in the big world with all of us humans, we always figure out how to do crazy things, and surely somebody will find a way to scratch up that cooktop. The one good thing I can tell you, though, is that you won't run into the situation where you melt a container into the cooktop. I've seen that with some of the folks that have the electric resistance glass cooktops, and they leave a pot on it a long time, and the pot boils dry. And it gets super hot and melts the top or mars the top. With the induction, you won't get that because the things, they have high limit switches on them. So if you run a pan dry, they tend to rise in temperature, cut themselves off. And yeah, so there we go. Panama, any other questions in that line, or are we good to move forward?
Last one, we can move on. Any comments about electromagnetic field radiation and pacemakers?
Yeah, so this is, so Panama and I were talking about this one yesterday. Years ago, we did a little measurement on commercial cooktops with EMF meters, and didn't find that the field extended very far. And when you use a pan and you're sort of playing around with it, you can see that the field doesn't extend very far, but it is a relatively strong field in the area that it's in. Once again, we are not medical experts, but in the stuff that we've read, and also in the stuff that Panama's read, we've not seen anybody saying that pacemakers are heavily affected by this field any more than normal caution. What we need to keep in mind is that the United States is is tailing in this technology, in adoption of this technology. Europe and Asia have adopted induction cooktops, both residential and commercial, many years before us. And I think we would be seeing, all kinds of information if we were seeing people really having serious issues with the EMF. But having said that, we still would love, and I make this invitation now, we would love to get some funding to get some EMF meters and go back and take our residential and commercial equipment and actually find out how strong that field is. It's always good to have data. That's our opinion. All right, Panama, can we move forward? We good?
No, please do.
Okay, so overcoming residential consumer concerns. How do we do that? We do that with science. And so there was a great report that was funded by SMUD. Thank you to SMUD that we worked on here at Frontier Energy. Let's talk about this a little bit. And this report, the whole notion was to try and bring this equipment into the lab, get some numbers, and really see what's going on. So we brought in 6 range tops. On the left here, we have our, oops, sorry about that. I need to, there we go. Let's get this guy going again. All right. On the left here, we have our induction cooktops. We have a Frigidaire, a GE, and a Samsung. And on the right, we have 2 traditional electric resistance cooktops, and then we have a Samsung gas range top right down there at the bottom. All of this laid out in the report. The report, by the way, thank you, Panama, and the Building Decarbonization Coalition, is posted at the same place where you registered for today's class. You can pull that report down and have a look at it. So the notion was to get in and look at performance. And the thing that I think most people care about is how does the induction range top compare when it comes to heating things up. So now you could say, well, induction cooks your food twice as fast. What we really are looking at is production capacity and practical uses of the induction versus the gas range. So, growing up through high school, I worked in a pasta restaurant. The most frustrating thing was trying to bring water up to temperature when you were running low on pasta. And then I have 4 kids, and pasta, of course, is a big part of any family's meals, particularly when you have 4 kids. And in fact, we had pasta last night at my house. So, everybody's hungry. They are complaining, hey, how quick can you get me dinner? So, what we are trying to show with this chart is how quickly can I get that water for my pasta big. I've got 12 pounds of water in a stock pot. I want to turn that on. It's at 70 degrees. How quickly can I get up to a couple hundred degrees? The reason we choose, just for you tech nerds out there, the reason we cut the test off at 212 is, or excuse me, at 200. As you move closer to 212, it gets harder to find an endpoint, right? You go through that phase change. And this is a test that we actually designed for commercial range tops 30 years ago. I wrote this test method when I was still a pup. Okay. So let's look at some answers here. What do we got going? Well, on my red side here, sorry, I should be using my finger instead of my fancy pen. Okay, oops. Okay, guys, I'm having a tech morning. Let's just restart this slide here. There we go. All right, maybe I'll use there we go. Okay. Let's see if we can make this work again. So on the left side here, I've got my induction cooktops, and I start them off at 70 degrees. Oops. Okay. There we go. Start them off at 70 degrees, and I am up to 200 degrees right up here. Somewhere around 10 minutes, an average of about 10 minutes, okay? That's great. And at that point, a couple of minutes later, my water's boiling, and then I'm gonna cook my noodles. And it's gonna take me the same amount of time to cook my noodles in that boiling water, regardless of the type of range top I'm using. What I really care the most about is how quickly can I get that water up to temperature. Over here in green, Okay, these guys are my electric resistance range tops, and then here's my gas burner in blue. And if you look, I'm crossing the line. What I really want to compare today is my induction cooktops against my gas range top. And here I am, and it's taken me about 18 minutes, 18 and a half minutes, something like that, to reach that 200 degrees. Last night when my very hungry kids were complaining about me not cooking dinner fast enough because I was working on this presentation, you know, what did I want to choose? I would choose that faster 10-minute heat up rate. That's a lot of time. That's basically doubling my production. Let's look at this from a number. And once again, I hate to show charts, but this is a great one. It's in the report. Just want to show a couple of things here. So here we have all of our input rates for the various range tops. So here's my gas range top. It is at 17,000 BTU per hour. And my induction range tops here, they're all listed in KW. So Sherry Davis over at SMUD had a great idea. She said, Richard, I would like to know equivalent BTUs. So we converted everything over to thousands of BTU per hour. So now I can compare my gas range top, 17,000 BTU per hour, to my induction, which is averaging out at about 12,000 BTU per hour. So you would say, wow, Richard, there's less BTU per hour coming out of the induction. What's going on there? Wouldn't it be slower? And in fact, here are those times. There was the heat up time for the gas at about 18 minutes. Here's the heat up time for the induction. It's averaging out at about 10 minutes. That's pretty amazing. Why is the induction moving so much faster than that gas range top? And it really comes down to efficiency. The induction, because the induction range top is not creating any heat, it doesn't create any excess heat. All of the energy is really going into the pot or pan. So we have very high efficiencies up in the 80% range. Whereas with my gas range top, just by design, it's a much simpler burner design, a much simpler heat transfer, and I'm at, you know, down around 32%. So what does that mean from a production capacity? How many pounds? Well, man, I've had times when I've had all my kids and all their friends over at the house, and I'm trying to really cook a lot of pasta then. What does that mean? Well, I can get, you know, 73.5 pounds of water up to temperature in an hour on my induction cooktop versus 38 pounds per hour, right? That just lays it out. Is a lot more capacity in that induction cooktop. Now, I want to point out one other important thing. If you look at our resistance, our traditional resistance coil cooktops, you'll notice that they have elements that are rated in the 2.5 to 2.4, or around 2.5 kW, okay? How come I can get these induction elements so much higher, the induction hob so much higher? And I think this is a really important feature that we need to pay attention to with really good residential induction cooktops. The beauty of the induction cooktops is they have electronics and they have computer control. They're smart appliances. And each one of the ones that we tested actually had a power boost mode or high input rate mode. And so those three hobs can actually go up to a much higher kW. And that's really brilliant, because what it means is that I can put as much energy as possible into those hobs, into those bigger hobs, and really get a lot of water heated up without having to put a much bigger electrical panel on the side of my house. In other words, I could replace these resistance range tops with the induction range top and put it on the same exact circuit. Now, so then you're going to be like, well, Richard, these induction range tops, they have higher ratings. What happens when you turn them all on? Isn't that going to overload the circuit? The beauty of the induction range tops is, as you turn on more of the induction hobs of those units on top, they say, hey, there's another one coming on, there's another one coming on, and they start to back down their power so that the range top still stays within its breaker rating, its current rating. It's something that you cannot do with a regular resistance coil range top, and I think it is a real huge feature on these nice induction cooktops. Okay, so let's just look over here. Once again, I've got my chart. We've got our heat up times, 18 minutes, 9 minutes, and then we get down to our efficiencies. Remember, I got that much faster heat up time because I had this 85% efficiency versus this 30% efficiency. And so once again, Sherry at SMUD was like, Richard, what's the theory there? Tell me what the heck is going on. And so we said, well, hey, let's go back to our equivalent BTUs. So this is this number here. My induction range top, you know, let's take this first example, is that equivalent BTU of about 12.3. And when I multiply that times my 85% efficiency, I get an effective BTU delivered to the water of about 10,000 BTU per hour. On my gas range top, I have that much higher 17,000 BTU per hour that's coming through the burner, but my efficiency is only 30%, and I end up with an effective energy delivered to my water of about 5,000 BTU per hour. So that really explains what's going on. It really comes down to the ability of the induction range top to really effectively deliver heat where it's needed. Okay, let's move on to my next story. So you know about me making pasta for the kids, all that kind of good stuff. Lately, we've also been doing, my wife and I have a beautiful fig tree out in the backyard, live in Oakland. It's the paradise, greatest city on the planet. Thank you very much. And have a beautiful fig tree out in the backyard. And we've figured out that we can make fig preserves that will take us all the way through the winter. So we've been learning how to do preserves. So we took one day, and we were doing them on our gas range in the house, but one time we took all of our fixings and went out to my mother-in-law's house, who has a resistance ceramic electric range. And we started making the jam out there, and damned if we didn't burn it, right? The bottom of the pan was scorched, and I'm such a careful guy, and it's like, what happened there? And what happened is that when you turn off the heat on an induction range top, or you turn off the heat on a regular gas range top, the heat's off, and there's a little residual heat, but it basically stops inputting any extra heat, and you have some controllability. On those traditional resistance range tops, particularly the ones with a ceramic top, they build up a lot of stored heat in the coil or in the glass cooktop, and they actually overshoot that temperature. So in our test, when we were testing that water and taking it up to 200 degrees, we would turn off whatever the cooktop was at 200 degrees and then see how much the temperature continued to rise. And here's why I burned the jam, because on that ceramic cooktop, that temperature just rose another 7 degrees. And anybody who's made jam knows you have to really keep an eye on that final temperature. You don't want it to scorch. It's a time and temperature kind of deal. And then the other problem was, not only does it go 7 degrees above temperature, it takes it a long time to give up any of that residual heat. There's like 38 minutes that it will sit up above 190 degrees. And so, I went back and I looked at the jam book, and lo and behold, in the recipe, it says, remove from heat. Oh man, why didn't I think of that? But I hadn't really worked with these ceramic cooktops before and didn't think about that overshoot. So what's that look like in a picture? Let's look at a picture of that. So here is, once again, on this side, these are our induction cooktops. And what we're doing here is looking really at a blow up of that chart I showed you a minute ago. So we hit our 200 degrees, and you can see that the induction cooktops, they have a little bit of overshoot, but not very much. It's like less than a degree. And then the temperature drops really quickly, okay? That's because all the residual heat is just in the pan. There's no real residual heat. There's no heat coming off of the cooktop, and there's a little bit of residual heat underneath the pan, but that's it. And you can see my gas burner, it's the same way. It has a little bit of overshoot, but it actually comes down pretty quickly, right? There's some residual heat in here and here, just the metal grates, the top of the range top. But check it out. Here's the one I was just talking about. This is that resistance cooktop. And you can see that here's my overshoot. It really goes up pretty far. And then it stays up there for a long time. It's above 200 degrees for a long time. And in our test, we waited for it to get all the way down to 190. And that's where it took that 38 minutes, right? So that's one of those performance issues that once again, makes induction great. And now there's another part of this that I think is pretty important, which is the safety aspect. If I have something that's going to stay hot for 38 minutes, that's a thing where you're saying, hey kids, stay away. Don't anybody put a rag on it. Don't put your hand down on it. There's just that chance somebody's going to walk up again and get burned. Whereas the induction, it's back down to temperature pretty quickly, right? So I just put that in as an extra benefit. Now, how do we get people to understand all of this stuff? Because I can talk theory all day and show you charts, and right about now you're having your second espresso, and you're like, why did they get an engineer to talk about this? What we need is hands-on, okay? Hands-on changes hearts and minds. And once again, nice graphic from SMUD. This is some research they did where they brought customers in and they had them try out induction cooktops. So if we look at our graphic here, the impression before was, what, about 80% negative. And those are those people that are saying, hey, I'll never use an electric range top because I hate them. And that's because they've always used, the traditional coil type range tops. Then you get your hands on the induction cooker, you work with it a little bit, and now we're talking about a 91% positive. People saying, oh, hey, this is cool. I had no idea. This is amazing. And I just think this is our goal. Ultimately, we have to get people hands-on using this equipment. This is what's going to change hearts and minds above everything else that we try to do. And I just want to, I know that a lot of people on the line, a lot of people we're working with are doing loaner programs. And I think the loaner programs are great because that does get people kind of understanding, like this induction technology is different and it actually works and it's very simple to clean. It's, it's all great stuff. But the thing that I want to continue to point out is that this, the little loaner single hob induction cooktop is way different from that very nice, full-on range top that we did our test on, primarily because this guy, the little loaner, does not have that power boost unit, and it's limited by the current that can come in. It also may have a fan on it that makes it a little bit noisy. That's one of the complaints that people have come up and talked to me about, is they can hear it, whereas the big range, it also is going to have heat control, but it's spread out. You're not hearing it. It's not so focused. So I think that what we need to do for these loaner programs, here's another invitation, I think we need to create some facts. As we loan these things out, I think we need to be telling people, hey, this is just a little taste, but you guys really should, come in and try the bigger stuff. And I also want to talk about this just for a moment. We need to get on point about why induction range tops are crucial to decarbonization. There's some articles that have been saying, hey, it's just great, they're great for you, performance, blah, blah, blah. But I think what we really need to do is go back, and I went back and looked at the New York Times article, and those guys, it was an interesting article, got a lot of negative comments, sadly, from readers, like 700 comments, and about 500 were negative. But I think that's because people didn't really read a couple of the important lines in there, and I think we as promoters of the technology need to pay attention to this. So here's one of the lines. Nobody is going to shed a tear about having to switch to a more efficient furnace or water heater, but people feel emotional about gas stoves. Okay, and that's absolutely true. Stoves actually use very little energy, but until people are convinced there are superior alternatives to gas stoves, we will not be able to get rid of gas lines to buildings. This is the core, right? We're really trying to change hearts and minds so that you could get rid of that gas line to the building. So I just want to pitch that out there. I think we need to really make sure that we're on point as we do our communications. I've seen a couple of communications that actually produce more blowback from consumers than positive movement. I also want to say I think we need to sell induction range tops in the same way as people sold smartphones. I'm old enough to remember when I had one big black phone that sat in the house that was just tied to the wall, and and now I've got this incredible computer in my pocket, and I think that's where we need to go. We need to tell people, hey, the induction cooktop is like your smartphone. It does amazing things that the old, 19th century technology doesn't do. All right, Panama, let's take a quick moment for some questions, and then we'll move into commercial food service, which I will move very quickly through. What do we got?
Great. Sorry about the background noise, folks, but one from Brian Ward. Is the higher kW in induction responsible for the quicker rise to temperature?
Yes, Brian, absolutely. That power boost in the induction elements, it ups the amount of BTU that I can get into the pot and into the water. So yes, absolutely increases their performance.
Great. And then a question from Don Pillsbury. Do you have any data about the gas's impact on the indoor air quality versus induction?
I don't really have data on that, and I know there is information out there about indoor air quality. I'll say conclusively that the burning of gas in a commercial food service situation is not going to affect the air quality at all, because you're moving so much air through the building. In my 100-year-old house, it's probably leaky enough that the burning of natural gas there is not going to be a big deal. I think where that really comes into play and is most important is in situations where you're talking about a zero net energy house that's very tightly insulated. Then you're looking at indoor air quality issues. And we actually have a lab up in Chicago that is doing some work on that right now on the ventilation aspects of residential cooktops. So stay tuned. But yes, it is an issue. Any other questions there?
Yes. Are there induction cooktops that have a setting that enables a low simmer, boil, rolling boil?
Oh yes, absolutely great. So that gets back to that notion of control. The beautiful thing about, so I get back to my jam cooking, okay? So I'm cooking jam on my gas range top in my house, and I have two problems. One is that the ancient burners on there are uneven, so I'm always having to stir and pay really attention. The other thing is I'm always dialing the heat up and down and playing with it. And my wife used to do truffles, chocolate truffles as well, right? And so I know about tempering chocolate and that kind of stuff. The beauty of the induction range top is you can set it at many different settings, a low, a medium, a high, and it will always reproduce that same setting again. So not only would I get, if I was cooking jam on an induction range top, I would have a very uniform heat in the pot. So I don't have to worry about hot spots or scorching. I could also know that, setting number 5 on my cooktop will always give me the temperature that I need for a certain batch of fruit that I'm trying to reduce. And it will just be the same every time. I don't have to sit there and play with it. So yes, absolutely, you can get simmers. You can, in tempering chocolate, I want 180 degrees. I can figure out which setting is 180 degrees. And some of the commercial cooktops actually have some temperature feedback, and you can say, hey, I want the thing to be 180 degrees, and it will take it right there. So that's another huge benefit.
Great. Can you talk about woks and using woks with an induction range?
I'm about to get there, so that's a perfect setup for our next section here, which I'm going to move quickly through this first little bit. And is that okay to move forward,
Yep.
Panama? Can we go? Okay, great.
Yeah, I'll save some of the remaining ones for the very end. Thank you,
Okay.
Richard.
Excellent. So let's talk a little bit about commercial food service, which is near and dear to our hearts. And we want to talk a moment about energy use intensity. Why do we care about food service? So this is thousands of BTU per square foot. Let's see, let's fire up my pen again here. There we go. I'm sorry, guys, I have a new computer and I'm just still getting used to all the touch screen and all the fun stuff I can do. It's a slightly different from my last one, so I'm going to blame my faux pas on still learning the technology. Okay, so anyway, here we are. We're talking about thousands of BTU per square foot. That's an energy use intensity number. Any of you energy experts out there deal with this all the time. And if you look at commercial food service, it's running at about 350 kBTU per square foot. Okay, here's my restaurant over here. Now that's an average number for food service. And you go compare that against a hotel, it's 5 times more. Against normal retail, it's 7 times more. If this restaurant is a quick service restaurant or anything it's got more kitchen to it, that number, that 350 energy use intensity goes way up, okay? What that means is that you're driving down the street and you see a McDonald's next to a Best Buy, and your brain is going to say, hey, that Best Buy uses a lot more energy, and in fact, they could be using the same amount of energy. They could have the same energy bill. What does this say for us when it comes down to sort of green building stuff? Well, let's say we were going to try to get to a zero net energy building like the Bullet building here, and now we're trying to get down into 18 kBTU per square foot, okay? I wonder if I can do that in food service. Well, here's the average energy use intensity for food service at 350. This is a quick service restaurant. If I'm trying to do a zero net energy McDonald's, I'm up here at 800. I got to go from there to there. I hope that illustrates a little bit just how energy intensive commercial food service is. From a cost standpoint, commercial food service is, operators are buying about $43 billion worth of energy a year. You compare that to all of the equipment supply, tabletop, furniture, everything, that's about $13 billion a year. So the energy bill is way more than all of the stuff you see when you walk into a restaurant, all the hardware. It's a big energy bill. In California, that's about $5 billion worth of energy, and it's 10 to 15% of the total energy revenue. Any utility people on the line out there? I'm just going to repeat that, okay? Your commercial food service customers are 10 to 15% of your total utility revenue. And so it's very important to look at this market and take care of this customer segment. From a social standpoint, about 10% of the US workforce is in commercial food service. And basically, everybody's touched by food service every day, okay? And there's some major challenges facing our food service operators right now. Probably labor being the biggest one. Anybody in the Bay Area knows that every restaurant's got a sign on the door saying, hey, help wanted, or lots of them are closing because they can't get enough people. Real estate, the cost of real estate is way up. We need to do ever more cooking in ever smaller spaces. The kitchen environment is pretty brutal. Nobody, necessarily enjoys working in high temperature situations, and there are actually some new heat stress regulations coming down the line. And then of course, electrification, decarbonization, that's sort of confusing to people, and it could actually change the amount of money that it costs to operate a restaurant. The good news is induction is definitely a solution to some of these challenges. And so now let's get into that. What are some of the things? Well, induction is fast. Hey, that helps with the labor. It's flexible. I can put it in all different kinds of situations, so I can build a smaller kitchen. It's modular. I can just install as much induction as I want. Highly efficient. That helps to lower my bills. It's very controllable. That helps to cut my food waste. It's way safer. It's also easier to clean, so that keeps my workers' comp down. It keeps my employee safety up. And at the end of the night, you wipe the thing down and you're not taking it all apart and trying to clean up burners. And there's less heat released to the kitchen as well. And there's a lot of different form factors in induction these days, which is great. These are some of the ones we've had in the lab, and lots of interesting stuff, like their tabletop units, their standalone units, their drop-in units, their stock pot ranges now. And then there's woks, and this was one of the questions somebody just asked. And so let's go back 25 years to some energy work we did on some woks. This one, that's a 5 kW induction wok right there. See if I can get my pen to fire up. There we go. 5 kW induction wok, and with a very high efficiency, and I can produce 117 pounds per hour of food. Here's the traditional wok, and its efficiency so low that it's producing about 124 pounds per hour. These guys are pretty close, right? Even though in size they're way different. So what's been the challenge of these woks? People will say, well, that's not a true Chinese wok. It doesn't look like something they would use in China. Amazingly enough, I did see these in China when I was over there, but I can understand that. I can understand people saying they really want an induction wok to look like a real wok. Well, hey, good news. At the National Restaurant Association show this year, they were showing off a full-on, Chinese wok. So it's coming to the U.S. market. And then on top of that, there's all kind of cool gizmos you can get for warming and holding and all this kind of good stuff. So let's do it. Let's do a quick comparison of a couple of range tops. Here's a gas range top from a case study that we did. And we did a cost analysis, and that was about $1,000 a year to operate. And the same size, the 6-burner induction, would also be about $1,000 a year to operate. So no big cost increase to go all electric with the induction, which is great. That's not true for every appliance, but that does work for the induction range top. So what are some of the benefits? Well, if I'm looking at a gas range top, what are the benefits with that? It's a lower capital cost, and it is indestructible. Somebody asked me one time, how long will a commercial gas range top last? And I said, 1,000 years. And but on the plus side of the induction, it is, once again, safer, easier to clean, and less heat to the kitchen. It cuts some of that heat out, which is really important. It also, as we started looking at some ancillary benefits, and oh man, am I giving you another chart here, but I'll go quickly through this one. This is capture and containment. It basically means how much air do I have to move through a kitchen in order to get the smoke and heat out. And I'm going to compare 3 range tops here, a gas one, and an electric range top, and an induction range top. And this basically is important because every cubic foot of air that I move cost me a bunch of money, because it's once through the building and I'm heating it or I'm air conditioning it. So you can see, in order to capture the heat and smoke of a gas range top, I need significantly more air movement than I do for an induction range top, right? So there's a benefit there. Smaller kitchen, smaller exhaust hood, less air movement. There's some ancillary savings. And then on the heat gain side, same kind of thing. This time I'm looking at the radiant heat to the space, right? How much radiant heat is coming off when I'm standing there? Well, if I'm boiling some water on a big commercial range top, I got a pretty good amount of heat gain. I basically have zero radiant heat off of the electric or the induction. Okay. Now, here's the interesting thing. If I take the water off and I just have the burners turned on, everybody's probably been to a restaurant and seen a gas range with all the burners turned on. I have this much radiant heat gain in space. It actually goes up. And if I take the pots off of the electric one, look at that. It goes from 0, way high up to 17,000 BTU per hour. But look at there. The induction, of course, still stays at 0 heat gain because when I take the pots off the induction cooktop, it uses no energy, it produces no heat. So once again, ancillary benefits. Let's look at a couple of pieces of equipment, little data that came out of a CEC study. We looked at soup warmers. In the lab, we saw a 69% energy reduction for induction soup warmers. In the field, we were seeing 64%, right? And you can see that we tested a lot of different units. Basically, the other thing I like is the performance really evened out as we went to the induction units. Here is a little restaurant in Oakland where we replaced a hot plate with an induction unit, cut the energy use by 59%. That was savings to this small business of $600 a year, which I guarantee you is a lot. Now, we always ask chefs, what could you do with $600 a year? Here's some not so good news that I just want to pitch in, the little sidebar about going all electric, okay? Electric appliances can cost significantly more to operate, so we need to design smart in order to achieve decarbonization. This is an invitation to anybody out there who's doing a job to come contact us at the Food Service Technology Center, work with us on the front end. If you go and do a one-for-one replacement of electric with gas, you're going to end up with higher utility bills. This is also an invitation for those folks in the municipal sector who are working on codes, laws. We need to look specifically at food service and make sure you do not impact your food service customers. Let me give you 3 examples. A griddle, a very typical piece of equipment that is typically gas powered in a restaurant. It's $1,200 a year for the gas, and it's $3,000 for the electric version, doing the same amount of work. The fryer, $1,600 versus $3,700. For a traditional convection oven, $1,000 versus $2,000, right? You can basically see that for these standard pieces of equipment, going electric can double your cost. The way around that is to design smart so that we need less equipment, we lower the overall energy use of the entire facility, and that could be looking at your hot water systems, your kitchen ventilation, making your kitchen smaller, okay? Ultimately, this is what we're trying to do. We're trying to replace a really big traditional cook line where you got one of everything and a bunch of low-paid staff working on it. We want to move to a much smaller cook line that uses a lot of high-tech equipment like the induction cooktop and has highly paid, highly trained professionals who are running all the equipment. That's one of our big visions and goals here at the Food Service Technology Center. Now, the tools to get it done. How are we going to change hearts and minds? Do we have this in our hands? Well, we do. Here at the center, we have a demonstration facility. We can bring people in and get hands-on, right? And I know people are doing the loaner programs for residential. I think also in residential, we really need to set up some centers where we can set up real residential ranges and have people come in and work with a chef. This guy right here, Mark Dusler, is our consulting chef. He knows his stuff. He's really excellent. The quality of food and eating around this lab has gone up tremendously since Mark has been here. And it does not cost PG&E customers a penny to come in and demo this equipment. So let me give you a great example of how that worked. Peter Turnbull over at PG&E, who is a friend of ours for many, many years, said to Panama, hey, Panama, you need to go out and meet these guys at the Food Service Technology Center. Panama came out, we sat down together, we hit it off wonderfully, and then very shortly thereafter, Panama said, to a sustainability manager in Fremont, hey, you need to talk to these guys at the Food Service Technology Center. And just so happens they were trying to build a senior sitter, and they were trying to get their chef to consider induction cooking, electrification, high efficiency equipment, right? Chef came out, worked with Mark Dusler, tried out some equipment, and this is what he said after coming and getting his hands on it. He said, after the presentation and testing some of the equipment, I am confident that they are just as good or better than conventional cooking equipment. I am and would be a happy chef with using more energy efficient appliances. green light for me. And let me tell you guys, that is the absolute best that it gets, okay? That's why we exist, but that's what we need to do if we're gonna make this, if we're gonna make all this stuff work. That's the end of this, my jabbering section here. Panama, what kind of questions do we have in our final few minutes?
Great presentation, Richard. As always, you met expectations and they're high for you.
Great.
We have a question from Nehemiah Stone about why do you use 200 degrees in your testing for boiling water when he feels like you should be potentially using 212 degrees near sea level?
Yes, yeah. So I touched on that earlier, and let me go back and explain a little bit further. As you move towards, and if you ever ran this test, I mean, here's your home experiment, okay? You go get a thermometer and try and figure out when you hit 212 degrees. As you move towards 212 degrees, you start to go through the phase change of the water, and it becomes very difficult to find that exact endpoint. Because it will drift in and out. It'll be 210, and then 212, and then 211, and it bounces around. So it's very hard to say exactly where the 212 is unless you let it run for a while. And that's not terribly fair when you're trying to design a test that is very repeatable and fair for every single appliance. You can hit a 200-degree endpoint precisely again and again and again. So that's why we use the 200 degrees.
Great.
Other questions?
Thank you. Yep, we'll run through a few more of these in the remaining 5 minutes.
Okay.
Are induction grills a thing?
So if you're talking about griddles, a grill in our commercial lingo would be a griddle. And there are induction griddles. We have one in the lab here. And yes, we can see those being a good technology because one of the challenges in the commercial world is trying to get griddles that are uniform so that the burger in the middle cooks the same as the burger out on the edge of the griddle. Or the pancakes, you know, think about loading the whole thing up with pancakes. And so the induction, the notion of spreading that energy evenly across the griddle surface is very attractive. Now, if you're thinking of a grill like a backyard barbecue grill, one where you get char marks, there is no induction version of that yet. There's that, and in a commercial world, that would be called a broiler, and there's no induction broiler as of yet.
Okay. Are there any water savings from using an induction wok compared to using a gas wok?
Oh yeah, absolutely. Yeah, I mean like Olympic swimming pool water savings because for anybody that's been around a traditional gas wok, in most instances, you have to run so much water, you know, you have to run a lot of water across the top of the wok, partially to keep it more comfortable, partially to keep it from melting itself. Yeah, and an induction wok needs zero water. It does not have that problem. Remember when I showed you the efficiency of that 100,000 BTU per hour gas wok, it was 19% efficient. That means 80,000 BTU per hour of heat is escaping around the wok bowl onto the surface and into the surrounding air. So yes, massive water savings.
Great. As we look to fuel switch from gas to electric cooktops in apartments, is there any good electric cooking equipment that could run on a single 20 amp, 120 volt circuit?
That's really interesting. Yeah, I mean, you're ultimately cooking is all about how much energy you can deliver to whatever, you know, you're trying to cook, right? And so if you have a 20 amp circuit, you're always going to be limited to about, you know, 1800 watts, and then it becomes, what are you cooking? How, you know, how concentrated is that? How efficient is it? What kind of controls you get? You know, there are some decent single hob plug-in induction cooktops that you could put in an apartment that would work fine off a 20 amp circuit. It won't have necessarily the same, you know, butt kicking power as that full-on range top, but yeah, absolutely.
Okay. And Redwood Energy has actually done a lot of work looking at low amperage, low voltage cooking technology, and they have a guide. And Michael, I'll contact me offline. I'll send you that guide. Yeah. And unfortunately, we have a ton of questions and not a lot of time. So what I'm going to do is, unfortunately, call an end to the webinar. I think the amount of questions just reflect the amount of interest in this space. And so I really want to thank Richard for the presentation and the work that you do out of the Food Service Technology Center. I highly recommend anybody in Northern California take advantage of the resource that they provide out there. And I want to thank everybody for joining in. We had a consistent about 75 people calling in for this. So please do join us for future webinars, and a round of muted applause for Richard, please.
Yay.
Thank you very much from the Building Decarbonization Coalition.
And thank you, Panama. Take care.